You ever wonder how services like Netflix or Google can just work? How they run thousands of different things all at once without the whole system just, falling apart? Well, the secret sauce behind so much of our digital world is a technology called virtualization. It's this wild idea that one single powerful computer can pretend to be many different computers. And in this explainer, we're going to break down how that one concept completely changed the game.
So to really get why virtualization was such a revolution, we need to hop in a time machine and go back about, say, 15 years. See, back then, data centers had this huge, expensive problem. They were packed to the gills with powerful servers. But honestly, most of that power was just sitting around doing absolutely nothing.
Just try to picture a data center from that time. If you needed a new email server, you had to go buy a big, physical machine just for that. Needed a file server? Yep, you bought another one. A database? You guessed it, a whole other completely separate physical box. This was the rule. One server, one application. And it was just how things were done. And this, of course, led to just incredible waste. I mean, think about it. A single application might only use like 5 or 10% of a server's processing power. That meant all the rest of that expensive hardware and all the electricity needed to run it and keep it cool was just sitting there, idle. The new way with virtualization lets us pack tons of applications onto one machine so we can finally use all that power we're paying for. So, some really smart engineers started asking a pretty simple question. Hey, instead of letting all this hardware go to waste, what if we could just make one physical server act like many different separate servers? And that right there is the big idea behind virtualization. The real workhorse that makes it all happen, that's the virtual machine. So what in the world is a virtual machine, or a VM, anyway? Well, it's not a box you can go and touch. A VM is really just a self-contained digital file that does a perfect impression of a real computer. It's got its own virtual processor, its own virtual memory, and its own virtual storage, all cleverly carved out from the physical machine it's living on. As far as the software inside is concerned, it looks and feels exactly like a real computer. Okay, to really wrap your head around this, there are two terms you gotta know. First is the host OS. That's the main operating system running on the actual physical computer, like Windows 10 on your laptop. Then you have the guest OS. That's the operating system running inside the virtual machine. So yeah, you could totally be running a full version of Linux as a guest, right on top of your Windows host. Pretty cool, right? So you're probably thinking, okay, what's the magic trick here? How can one computer pretend to be a bunch of different computers at the exact same time without everything just crashing and burning? The answer is this really critical piece of software called the hypervisor. The hypervisor is basically the engine of virtualization. The best way to think of it is like a traffic cop for the computer's resources. It's the thing that creates all the virtual machines, and then it carves up the physical machine's real CPU power, its memory, its storage, and it hands out just the right amount to each VM, making absolutely sure they all play nice and don't get in each other's way. Now, not all hypervisors are built the same. They pretty much fall into two main buckets, Type 1 and Type 2. And the biggest difference between them really comes down to where they get installed. It all boils down to one simple question. Does the hypervisor get installed directly onto the bare metal server hardware itself, or does it run like a regular old application on top of an operating system you already have? The answer to that question tells you exactly which type you're looking at. All right, let's break these two down. A Type 1 hypervisor, people call it bare metal, runs directly on the server hardware. There's no operating system underneath it. This makes it super fast and efficient, which is why you'll find it in pretty much every big data center out there. Then you have Type 2, the hosted kind. This is just an app you install on your computer, like VMware Workstation or VirtualBox. It's awesome for developers and testers who need to run, say, a Linux environment on their Mac for a project. So let's just walk through a Type 2 setup to see all the layers. At the very bottom, you've got your physical hardware, your laptop. On top of that, you have your main operating system, your host OS, like Windows. Then you install the hypervisor software. That software creates and runs your virtual machine, which has its own operating system, the guest OS, like Linux. And then finally, inside that Linux bubble, you run your application. It's literally a computer within a computer. Okay, so we've covered the what and the how, but now we get to the really important part, the why. Why was this such a massive, earth-shattering shift for the entire tech industry? Well, the benefits are just huge. Virtualization basically comes in and solves all those problems from the old days. You need way less physical hardware, which means your power bill goes down and you don't need a giant room to store everything. But the real magic is the flexibility. Firing up a new server goes from a weeks-long project to something you can do in minutes, and things like maintenance and disaster recovery, they become so much simpler. And that brings us to maybe the most mind-blowing feature of all, live migration. Let's say a physical server needs an upgrade, or maybe it's about to fail. You can take a live, running virtual machine and move it to a completely different physical server with exactly zero downtime. The people using the application will never even know anything happened. This was an absolute game changer for reliability. When you get right down to it, the technical wizardry here is all about isolation. You can have Windows, a few flavors of Linux, and other operating systems all running at the same time on the same piece of hardware, but they're completely sandboxed from each other. If one of them has a problem and crashes, the others just keep on chugging along, totally unaffected. So, I'll leave you with this thought. We started this whole thing stuck with one server doing one job. Virtualization let us run dozens of servers on a single machine. But that was just the start. The ideas we've talked about today are what paved the road for modern cloud computing. The idea that the power of an entire data center could be managed like one giant, flexible, virtual resource. The revolution? Well, it just keeps going.